All right, so this is the beginning of chapter 7. We did not finish up chapter 6. It's okay. So we are jumping right into chapter 7. You don't need to write any of this down, but please know, SOHCAHTOA, it only works for right triangles. And I didn't know until I started teaching this concept a couple of years ago that some kids would just try to use SOHCAHTOA on everything. You can't. It's got to be right triangle or there's no hypotenuse for opposite over hypotenuse. SOHCAHTOA only works for right triangles. For oblique, that's non-right triangles, we have to have some other methods, and we're going to learn one of those methods today. If they ask you to solve the triangle, it means find all three sides and find all three angles. They'll give you some of them, but you've got to fill in the blanks and find the rest. That's what it means when it says solve the triangle. We've got 4 cases for solving a triangle. You don't need to write these down. You can just look at it. The first case is where you're given a side and 2 angles, and this is where we're going to put our focus today. And that's SAA or ASA. And you probably remember those little acronyms from geometry. You've probably seen those before. Case 2 is where they give you 2 sides and an angle. That's the one that makes the bad word. Yes, I wrote it backwards. And I kind of like that one's the bad word, because the one that makes the bad word is the one where it gets sticky. That's the one where you might have 2 options. You might have more than one answer, and we're going to talk about that on Friday. Case 3 is where they give you 2 sides and an included angle. We're going to talk about that, I think, Monday. And then they might give you 3 sides. Side, 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 and you can find 3 angles from that. So we're just focusing mostly today with case 1. And the method is called law of sines. Now you can start writing. Law of sines, here it is. Write it down. Obviously not hard to memorize because all the letters kind of match up. And you have to have that memorized. I will not provide that for you. If you were that kiddo that wants to know where this formula came from, I've got some stuff you can look through and it will tell you how that formula was derived. For most of you, you don't care and you'd rather just memorize it. How come these guys are lowercase on the top and these are capitals? Right. Lowercase are the sides. And our uppercase, of course, if it's got a trig function with it, it has to refer to an angle. So A over sine of A equals B over sine of B, which also equals C over sine of C. We're only going to do 3 examples today, and that's all you're going to need, trust me. It says solve the triangle, and it gives you some information. Bless you. I'm a picture person. I'm all about that picture because I kind of want to see what I've got when I don't have. So here's A, here's B, here's C. Angle A, it says, is 28.8 degrees. Angle C, it says, is 102.6 degrees. Side C. I've got 3 sides. How do I know which one that is? Across from angle C. Good. So that's 25.3. What I don't know is side A, side B, or angle B. So those 3 pieces are what I need to solve the triangle. And we're just going to use the law of sines to get us there. Now, to find angle B, do I have to use the law of sines? What could you also do? Right, 180 degrees minus 28.8 minus 102.6. And somebody borrowed my calculator, so somebody type that in and tell me what you get. Yeah, no problem. 48 point what? 6. Degrees. Don't forget your little degree bubble. So we found one piece, and now we need the sides. So we're just going to use law of sines. I need side A, so I'm going to say A over sine of angle A, and angle A is 28.8 degrees, equals. Should I use B over sine of B or C over sine of C, or does it matter? Why do you say C over sine of C? They gave that one to you. Now what's nice about this is we didn't have to round. It's exactly 48.6, so you could use B over sine of B, except we don't know what B is. So you'd have 2 unknowns. So that's kind of a problem. So let's do C over sine of C. So we have 25.3 over 102.6. Oops, sine of 102.6, my bad. Degrees. How do you get A by itself? You can cross multiply or just multiply both sides by sine of 28.8 degrees. So on the top we have 25.3 times sine of 28.8 degrees. We're going to divide by 10, whoops, I wrote something different, 102.6 degrees. Alright, somebody type all that in and tell me what you get. What'd you get? Should be in degree mode. Make sure your calculator's in degree mode. 12.5 if you round to the nearest tenth. What made you round to the nearest tenth? Everybody else has rounded to the nearest tenth. So we have 12.5, and what do we, thank you, inches. Good. So we have side A. All I have left that I need is side B. So I have B over sine of B. And angle B is 48.6 degrees. Equals, should I use C over sine of C or A over sine of A, or does it matter? Doesn't really matter, but what should you probably use? C over sine of C, because we had to round letter A. So we want to make this as accurate as possible. So we're going to use 25.3 over sine of 102.6 degrees. Multiply both sides by sine of 48.6. I realize, guys, that there are not a lot of steps to show, but there still are steps to show, so no steps, no credit. And what do you get? 19.5 is that what you guys got? Anybody else do that? Double check Ashley? Did anybody double check her? Okay, so 19.5 inches.
Oh, sorry.
0.4, thank you. So it definitely should be rounded to 0.4, thank you. Did we solve everything? Yeah, we've got all of our sides and all of our angles. We're set. Questions on first example? Good news for you, it doesn't get any harder than that. Ta-da! Hooray, right? All right, next example. We're only doing 3. Picture time. Jerry wishes to measure the distance across the Big Muddy River. So we've got distance across the Big Muddy River. It's not the Nile. That's funny. It's called Big Muddy River. That's the name. He determines that C is 117 degrees, and I'll just kind of set this up for you. I'll show you. It's okay. So full disclosure, like there actually is a whole diagram in your book that would do this for you, but I was too lazy last night to like type it all in because it takes a long time. So we're just gonna draw it. Sorry. So C is right here, and that's 117 degrees. And then we have this right here. There we go. This oh wait, did I do this wrong? B. Oh no, I have this distance. I think this is B, and I think this is supposed to be A, if I remember right. Side B, it says is 75.6 feet. And angle A is 28.8 degrees. Find the distance across the river. So it looks like we're looking for letter A. So we use our law of sines because it's not a right triangle. You can't do SOHCAHTOA. So A, which we don't know, over sine of angle A, which is 28.8 degrees, equals, do I do B over sine of B or C over sine of C, or what do I do? I don't know C, and I don't know angle B. Probably easiest to get what? Probably easiest to get B. So we're going to do 75.6 feet over sine of angle B, and angle B is going to be 180 minus 28.8 minus 117. What do you get?
34.2.
Thank you. 34.2 degrees. Multiply both sides by sine of 28.8. And then somebody tell me what you get. And then somebody else double check that person. You guys just let Ashley do all the work for everybody. 64.8. How did you get the same thing? She's working on it. Okay. 64.8, is that what you guys got? 64.8 feet. So we're talking about distance right here. Questions on that example? Last one has just sort of a little bit of an interesting piece to it. It's not hard. The word bearing is probably new for some of you. The problem says that the bearing of a lighthouse from a ship was found to be north 52 degrees west. Yee! All right, bearing is just sort of a directional kind of deal. Here's the thing. Here's the ship, and I'm going to put a little 1 because I know he's about to move. That's the first location of the ship, right there. And this direction right here, that is due north. The lighthouse was found to be 52 degrees west of north is what that means. So lighthouse is over here, and this right here is 52 degrees. Now I hope you're listening because this shows up on your assignment. If it doesn't tell you west and it just says the bearing is 52 degrees, you have to assume it means east. If it wants you to go west, it'll tell you. Otherwise, you assume it's east. Does everybody understand? Okay. So 52 degrees. After the ship sailed 5.8 kilometers due south, so we're going to go straight south. Here's the ship's new location, and he traveled 5.8 kilometers. Find the distance between the ship and the lighthouse at each location. Each location, how many answers do I have? 2. I just realized I did not do that with first hour because I didn't read. Shame on me. So this little angle right here is 23 degrees. So the bearing is different now. It's now 23 degrees. Does everybody see where I got that? It said it was 23 degrees. So that's the picture. And they want us to find the distance from the ship to the lighthouse right here, which across from that angle, it's called S sub 2. Across from this angle, it's going to be S sub 1. Tricky. I can see my triangle and I have exactly one angle. This is going to be tricky. What do I do? Yeah. We actually do know this guy right here. It's 180 minus 52. So somebody type that in and tell me what you get. 128. And then my triangle's kind of tiny, so I'm going to write sideways. All right, so now we can do something with this. Law of sines says that I can take first distance over the sine of S sub 1, which that's 128 degrees. It's supposed to equal, what do I put? Equals what over what? What's the only distance we do know? 5.8 right here, but do we know the angle that goes with it? We do now. It's 180 minus 128 minus 23 degrees, and what do you get? Okay, I don't have a calculator, so I'm going to assume you're right. 29? Okay. So this guy right here is 29 degrees. And now you multiply both sides by sine of 128 degrees. Type it all in, make sure you're in degree mode, tell me what you get. Everybody get 9.4 kilometers? Don't just assume she's right. She's pretty awesome, but, you know, she misses sometimes. Anybody? Did anybody double check that? Sammy, she's good? Okay. All right, so S sub 1, this is 9.4. We still need S sub 2, so we do law of sines again. So we have S sub 2 over sine of corresponding angle, which is 23 degrees, equals, I'm going to stick with 5.8 over 29, because did you have to round the 9.4, Ashley? Yes, she did. No, she didn't?
Yes, you did.
Yes, she did, she says. So I'm going to stick with what we know. And I strongly suggest you guys do the same. Let's go ahead and multiply both sides by sine of 23 degrees. .7 kilometers. Ta-da! We have our two distances. Questions on any of those examples? Are you already feeling like this is going to be a much better chapter?
yeah.
Yay! All right, here's your assignment.